6.1 An Introduction to Vectors. Scalars are quantities completely described by a number and perhaps a measurement unit. Vectors include a length, intensity, or size, a quantity, and a direction. So it has both a magnitude or a quantity and a direction. Time, example 1, does not have direction. It is a scalar. Position, yes, it has direction. Temperature goes up. Is that a direction? No. Scalar. Electrical charge, the amount of charge, scalar. Mass is scalar. Force has direction, vector. Displacement, vector. Geometric and algebraic vectors. Geometric vectors are vectors not related to any coordinate system, and they can be drawn using arrows. The length of the arrow indicates the magnitude of the vector, and of course the direction is the direction of the arrow. It's a directed line segment, A to B. So notice how the first letter is the start, called the tail or the start of the vector. B is the end, the terminal, head, or tip where the arrow ends up the vector when you're drawing it like that. So A to B is not the same as B to A. Okay, the order matters. Algebraic vectors are related to a coordinate system and usually Cartesian coordinates. These vectors are in general described by the components. So in this case, it is a three-component vector. We usually call this the X, Y, and Z component. And in 3 space, you can think about it this way. We have the x-axis coming out towards you. It's shown on an angle, but it's coming directly towards you. Y is going to the right, and Z is going up. Position vector is the directed line segment from the origin. The O is from the origin, so the vector starts at the origin where the tail is, and the tip or the end of the vector is at point P, O to P. So here we go. Let's add in some vectors here. Before we begin, though, I'm going to add in the axes. The origin, of course, is the intersection of the y and the x-axes. These aren't vectors. I'm just drawing in the axes. Okay. And now I'm going to draw a vector O to A. It starts here, goes there. There's O to A. That's the geometric vector. Algebraically, which is sort of a little bit extra, the component is 2 units to the left, 2 spaces left, and 3 up in the y direction. So O to A is -2. Sorry, that's up 2, not 3. Wish I could count. There we go. The B vector goes from O to B, goes from O to B. There it is geometrically. Algebraically, this vector has 3 units right and 0 units up or down. So 3 and 0 are the components. And we have vector O to C. Geometrically, algebraically, it is 3 right and 3 up. So 3 and 3. So I've included both the geometric and the algebraic vector. Displacement vectors do not start at the origin. They are from point A to point B. There should be a vector arrow on that. And this example, draw the displacement vectors P to Q. Well, there's it drawn. It doesn't ask for this, but I could do this as well. This vector goes 4 units to the right and the negative y direction 2 units. R to Q is drawn there. Algebraically, R to Q is 3 right and up 1. Okay, that's it for this video.